do this in like 2 minutes, is you look at this spectra, and looking at this spectra, you should immediately acknowledge that this is IR spectra. Because it is IR, you know that IR is talking about bonds vibrating. Are you responsible for all bonds vibrating? No, just those that vibrate officially greater than 1400, but because I'm such a nice guy, I usually aim 1600 and higher. Okay. This signal right here looks very broad. It's very intense, showing up about 3400, would suggest OH. It's a little pointy stabby for me, so I might go through and call that an NH with a question mark. Okay. Looking at that next range, this is CH. Those are all less than 3000. That would be sp3 hybridized. I now have structural information. Okay. Do I know what the structure is? No. I know nothing about how those bonds are connected to each other. I only know that I think those bonds are present. Okay? This 1600 right here, if I was feeling really spunky, I might call that a carbon-carbon double bond. Because I'm seeing a bunch of other bonds coming after that, I might even go through and call that aromatic. So what you're doing is looking at the spectral data, the peaks that you're seeing within it, and drawing conclusions about what those peaks mean about structure. Right? How much of what I've written is correct? I don't know, actually. Let's take a look. Oh, son of a, look at that. Carbon-oxygen double bond. Son of a, I didn't get that. I got the OH. I said carbon-carbon aromatic. There it is. Okay. Why did I miss the carbon-oxygen double bond? Probably because I can't count. No. That peak is actually due to the carbon-oxygen double bond. Why is it not falling where I would expect it to? Because of everybody's favorite, resonance. There's resonance within this structure which weakens that bond, and because the bond gets weaker, the signal shifts lower. Oh my God. This was the easy spectra to analyze. Okay? What you're responsible for doing is looking for those bonds and trying to match them to a structure. How are you going to match them to a structure on a test? Multiple choice. Okay? Okay? Here we've got mass spec. How do we know it's mass spec? Okay? I have to recognize the different axes to interpret what those different axes mean towards the individual spectra. Because it's mass spec, guess what I'm looking at? I'm looking at the mass of the particular molecule. Each of those peaks represents the mass of a particular piece of the molecule. Okay? This tallest one furthest to the right is my M plus signal. The M plus signal is the mass of my parent peak. What does that mean? 91 to, what was that, 3? 93 grams per mole is the molar mass of my compound. Because it is odd, I know nitrogen is present. Nitrogen weighs 14. 93 minus 14. This is where I got to slow down. I can't do that calculation. 79? 79, thank you. Okay, that 14 was my nitrogen. That 79, what elements could possibly be making up that mass? Okay, it's OChem, it's carbon and hydrogen. I have no evidence for any other element. I'm just going to say it's carbons and hydrogens. Okay, if I knew my times tables well, times 12 tables, 12 fits into 79 6 times? I don't know why I'm writing the 72 there. I think it's 6 times, which is 72. Okay, there's 7 left over. What do those 7 represent? Hydrogen. What does the 6 represent? Carbon. I have a formula, C6H7N. This video has been recording for 4 minutes, and we've interpreted IR and mass spec. Under 2 minutes each.
Where did you get the nitrogen from?
I got the nitrogen because it was an odd number. Hooray!
Odd numbers always nitrogen.
Odd number of nitrogens, yes. Okay. Now what happens? Carbon NMR. How do I know this is carbon NMR? Again, paying attention to the individual axes labels. The big thing that I zoom in on is this number greater than 15? Yes, I'm looking at carbon NMR. Okay? Carbon NMR, I see 1, 2, 3, 4, 5, 6 peaks. 6 peaks means there are 6 unique carbons in my structure. Of those carbons, this one is of alkane bonding geometry. All of these are probably aromatic, okay, but could also go with alkenes. And because I remembered back in the past unit my functional groups, I know that aromatic is referencing that 6-membered ring with the double bonds in it, and an alkene would just be the carbon-carbon double bond. The alkane would just be a carbon with hydrogens, or not necessarily hydrogens, all single bonds around it. Why would I jump to aromatic? The number of signals within that range is a lot. Okay? So an aromatic ring has 6 carbons in it. Okay? If carbon NMR is counting my carbons and they're all different, that's going to give me 6 different peaks. Okay? In this case, 5 different peaks within that range. That could explain what I'm seeing. Okay? Again, other things can fall in those ranges, but that ballpark gets me some information. What happens next? We move to the last one, which I definitely don't have time for. HNMR, the number I'm looking at. Again, that lower left-hand corner. Is that lower left-hand corner greater than 0 but less than 15? Okay? Because if it's 0, that's mass spec, or actually IR is up around 4,000. Okay? I'm now looking at HNMR. HNMR tells me about the amount of hydrogens. And this is where it gets fun. I see 4 sets of peaks. 4 sets equals 4 unique hydrogens. Less than 2, these are all alkanes. This one I have no clue about. Okay? I don't have the context to know what that hydrogen is connected to. But the less than 2, I know those are connected to carbons. Okay? There are 3 peaks within that set. 3 peaks equals 2 neighboring hydrogens, which could mean for that green signal, number 1, I have a hydrogen, and that hydrogen likely sees or has to see 2 hydrogens as neighbors. All I've done is analyze one of those 4 different signals. Now what do I do? Next signal, repeat. Next signal, repeat. Once all of that context has been done, I then have to make the wild assumption that they're all referencing the exact same compound, and now I can take all of those individual pieces of information that I've learned about the structure, and I assemble it to get a final compound. Guess what we're doing over the next 2 weeks? This. So we'll spend time looking at each of these, looking at where that information is coming from, and ultimately how to process it. Almost everything within this particular unit is about doing, not necessarily about the content itself. Highly encourage practice. To that end, that's what the lab is today. With that, we're going to go ahead and stop. Is that